The atom, as proved by Ernest Rutherford's famous gold foil experiments, is mostly empty space. But how come when I clap my hands or hit anything, the atoms of my hands don't pass straight through each other? How come they don't phase through? Well, this is because of the layout of the atom, which is surrounded by negatively charged electrons, and these electrons repel each other. But how exactly does that work? Well, first of all, this model or representation of the atom is called the Rutherford model, and it is completely wrong. This model is called a Bohr model, or the planetary model of the atom, and it's a little better. But for this case, we'll use a more accurate model, which is called the Schrödinger model. And there are other more specific models, but this is all we really need now. These dots surrounding the atom are electrons, but each dot is not actually an electron. In fact, where there are more dots, that just means there's more of a probability of an electron being there. There aren't that many electrons. So, when two atoms get close to each other, the negatively charged electrons surrounding each of them repel each other and repel the atoms. But how exactly do these electrons repel each other? Well, classical physics tells us that these electrons each have an electromagnetic field surrounding them, and it is the electromagnetic force that repels the electrons. But a field on a quantum scale doesn't really seem to make sense. This is where quantum electrodynamics, better known as QED, comes in. QED says that when electrons get close to each other, they exchange photons, each emitting one and each absorbing one. And while there are other possibilities, this is by far the most common. And because these photons do indeed have momentum, although they have no mass, the electrons move away from each other.